Hi, my name is Tim. My project is about echocardiogram image segmentation and data acquisition system. As what Tom Petty says, if you're not getting older, you're dead. So, unfortunately, we're all probably gonna face with heart diseases at one point of our lives. World Health Organization has shown that cardiovascular disease are the #1 cause of death globally, taking an estimated of 17.9 million lives each year. Based on experience of cooperating with doctors, we create a medical project in order to make systems for analyzing the measurements of the cardiac structures, to assist doctors gathering all symptoms and making the best diagnosis. The workflow divides into hospital, doctors, and system respectively. I'm in charge of the system, so we use computer vision algorithms to classify the structure of the cardiac and analyzing the measurements. The difference with other systems, instead of using samples from other databases, we take patients' echocardiograms from the sonographers, which isn't as clear as the former image. We hope these systems can bring lower cost for patients, where they can easily afford a personal data acquisition and tracking system. So, about the methods, some of the samples we had here were defective. I have mentioned the image we have isn't as clear as the database. For example, this frame's left atrium and left ventricle is defective. So, we use skeletonized to define the model of the systole and the diastole. Next, we can see the diastole model on the left and systole model on the right. Then add all frames to find the heart's boundary to block the broken myocardiogram. Then we had outlined the heart boundary in case they over-segmentate. Using the model to find the spetum and the valve, there's two spectrums. One is the atrium spetum and one is the ventricle spetum. So we all call it spetum. In order to divide the heart into 4 chambers, we have separated the atrium and the ventricle. When the valve is open and when it moves too fast, that cannot even be shown on the image. We transfer the echo into grayscale image, which can be seen as a topographic surface. The echo is fully compromised with noses, so we use marker-based watershed. In the end, we can see there are contours on each chambers. So, according to the results, we can see that the 4 chambers are perfectly separated. The last conclusion, we're building a fully automatic analysis system for echocardiogram, including image segmentation, view identification, and measurements of the structure. Analyzing parts of the heart, including atrium, ventricle, and myocardium, listing out the data of cardiac structures to assist doctor gathering all symptoms, making the best diagnosis that can detect specific disease, for example, tricuspid regurgitation, etc. This brings us to the end of the presentation. And always remember, listen to your heart, not the crowd. Thank you. If there's any questions, I'll see you in May 20th.